Hello, everyone. Uh, Welcome to another Spotlight session. My name is Alireza Darbehani, and I will be your host today. Today's session is on end-to-end recommender engine with AWS Glue and SageMaker. I have Hani Almousli with us today, who is going to talk about how his team leverages AWS technologies to build recommender engines. Hani, welcome to our Spotlight session. And before I pass the conversation to you, I would like to make some announcements. So we are having a couple of interesting sessions coming up, a Spotlight session coming up next week. On next Tuesday, April 21st, we would have the Founders Stream, Customer Analytics. On Wednesday, we actually have two events happening. Learning to play soccer by reinforcement learning, as well as a literature review on reinforcement learning in process control. And the next Thursday, we would have a talk about selfies, 100% robust representation of semantical constraint graphs for deep generative models. We would also, today is also the last day to sign up for our deep learning workshop, from theory to deployment. I would really suggest that because it goes end to end, teaching you the concepts of deep learning and also how to deploy it on cloud. Hani, please tell us about yourself and enlighten us about your work. Thanks.
Okay, so thanks everyone, and thanks for hosting me today. It's my pleasure to be presenting with you guys. So my name is Hani Almousli. I'm a director of data science at Royal Bank of Canada. So today I would like to speak about some of my personal work that I have done about building like a system from an end-to-end perspective with Amazon Glue and Amazon SageMaker, and talk about it from a recommender perspective. It's going to be more pedagogical example, but it's kind of like generalized, and you can do this for even more complex stuff that you need if you have it at your own work. Now, the one thing that I'd like to share before starting is that one of my main goals from this presentation is like, what are the takeaways that I want people to have? The first thing is just to get a high-level understanding about the services in Amazon, such as the Glue and the SageMaker, and how they can interact together. That's number one. The other thing is about Amazon SageMaker, and it's mainly focused for data scientists who don't have experience in software engineering or they have engineering skill set. Because I'm trying to push forward, and even in our team at RBC, we're always trying to push for data scientists to be a bit more aware of the software engineering, because data science in 95% of the organization is not a purely data science anymore. It's not like 2015 or 2016. Data scientists have to get a bit of an understanding on from an end-to-end perspective. Of course, there's like a gray area, but there should be a bit of a knowledge about the engineering aspect for it. And that's what I want to try people here, such that they will know roughly with, I want a SageMaker, use SageMaker, what's the input, like what's the output, how it's structured. And later even, and that's what we're trying to do with RBC, if you want to create our own application, how can we build a solution that's compatible with it? And even you can run it on your own without having a public cloud. So I have two blogs that I listed at the end as resources for people to go through lots of details. Because again, if you want to talk about it, it's going to take like a lot of time. So I'm trying to grasp ideas. And again, if you guys have any question, the facilitator will let me know, and then we can go through them. Okay, so let's start. So the first thing I would like to talk about is an overall architecture of the solution. So what I want to present here is, imagine that you have a batch-based solution where every week, for example, you have a bunch of data. You want to run a data transformation for it. And then once the data transformation is done, you want to run a machine learning algorithm to do a prediction. And that's kind of like very general use case, and it's very business kind of oriented, where we have a lot of businesses like that, even in RBC, where they want to score their clients, for example, or provide product recommendation, or apply any analytics on a weekly basis given certain metrics. So that's more of from a batch perspective. That's what I want to focus on. But again, SageMaker will give you an access to a deployed API that also we will talk about. So the first step that I want to do is that as an overall, think about that the data is coming from S3, from Amazon S3. The first thing is you want to apply data transformation because your data is raw. It's not in the right format that you would like it to have. So generally, you start using with AWS Glue crawler, and the crawler is mainly taking your data and putting a schema on top of it and save that schema on AWS Glue data catalog. So your data will be on S3, and then you will create a catalog or a schema around your data such that you can query that later. Then what you'll do as a next step is you'll take your data from the S3 with, of course, the schema that you created from the catalog, and then you use the AWS Glue ETL job, the job that you can schedule on demand or on whatever you want, and then transform your data, the raw data, using that schema that we created, and you put it back on S3. The next step would be now your data is ready for a machine learning model algorithm. Because in general, for example, you might need to do some merging if you have like 2 or 3 tables, for example. The input to the model is maybe one NumPy array. So that's why you need to take this data, transform it, massage it, clean it, and then put eventually the results back to S3 where it's a model ready. So the overall, I'll go in more details about that image for the SageMaker. But the idea is that the data is on S3. You call your training model. Once it's done, the result is back to S3, and then you can use, again, the deployment or the serving layer from SageMaker, and you can deploy it to an endpoint such that any client application can ask the endpoint a question as a REST API. Using the model artifact that you have in S3, it will return the results back. So the other thing that is really good about, and that I'm not going to cover in the presentation, and you can find it in the blog, is you can use also AWS Lambda and the API gateway for more complex functionality. So imagine that if I'm building a mobile application and it runs multiple SageMaker models, then you need like the orchestration and combine them together. Like you can relatively use Lambda such that if you have multiple results from different APIs, you combine them together and then send the results back to your final application. And of course, API gateway is also helpful in order to facilitate that step. So first of all, the first step, let's go with it step by step. The first step is the data catalog. So the data catalog, you will start by creating a crawler with a specific data on S3 that you want to run on demand, for example. You will run your crawler on S3, save the schema in a database, and the output of the schema will be saved in a table. It's pretty much important to understand that AWS Glue is not going to save your whole data. Your data is going to still be on S3, and the catalog is only saving the schema. So AWS Glue, think about it as an ETL job that you can run on demand or on a schedule. The cool thing about it is that it's purely serverless. It's like Amazon, the AWS Lambda, where there is no kind of like infrastructure that you need to worry about. So you specify your configuration, and then it will work for you and transform your data in a serverless manner. So that's roughly kind of like any ETL job that you want to run, you can use the Glue for. And it's important to know that your schema doesn't have your actual data. It will only have the schema, such as the name of the column, the type of the data that you have. Now, I'm going to walk, since we don't have a lot of time, I couldn't have like an actual AWS running and it takes time to launch all this stuff. So I have a pretty much detailed print screen, one by one, that I will go quickly on and show you what we want to do. So the example here, first of all, I have the movie lens data, which is used for different recommendation. And eventually, we're going to build a collaborative filtering algorithm for it. So first of all, you have to create your bucket on S3. And the data is, for example, called movie lens dataset. And I have my data inside that folder. That's the first step. So you put your data on S3. The next step is when you go to AWS Glue, under crawlers, as you can see on the left side, you can add crawler in order to crawl your data. So once you click on add crawler, you want, first of all, to specify the name of the crawler. And I'm saying movie lens crawler _ crawler, for example. And then you want to specify the data sources. Where are you getting your data from in order for the crawler to crawl? And in that case, I'm saying it's from S3, from that bucket, and I'm specifying exactly the name of the folder on S3 that I showed you on Hani test bucket, which is movie lens dataset. In that case, it will have 3 kind of like data sources, which is UData, UItem, UUser. and every one of those is going to be a separate table eventually, as we will see. Then you say, what's the IAM role? It's kind of like an AWS detail. Generally, if you want to run anything, it has to be in a role. And your role in that case has to get access to S3 and to be able to have the permission to run on AWS Glue. So then you say, how do you want to run this crawler? I'm saying, let's run it on demand. The name of the database that you will put your schema for the tables in, and I'm calling it Zeppelin database. And then that's the summary. So I created the crawler with that IAM role, and then the name of the database and where the data is coming from. And then I click on finish.
Hani, so I think the images are a bit small in the live stream. Can you please zoom in a little bit if possible?
Oh, okay. So for me, they look really good because I am already 184% zooming. So let me see. Because in that case, I might start losing some of the stuff on the edges.
Okay.
Is that okay? Is that better now? Like for me, it's pretty clear. Do you guys see it well?
Yeah, people say it's a little bit hard to see the text.
Okay, perfect.
Great, thanks.
Thank you. Okay, so maybe I'll spend a bit more time while I'm not going to go too quick because if it's not that clear, so people would have more time to look at them. Okay, so let's go back here. So now we created my crawler, which is called Movie Lens Crawler. That's the one. And what I can do right now is run that crawler on that data. So if I click on Run It Now, I can't move for some reason. Just 1 second. For some reason, the PDF is not working anymore. When I changed the zooming, I can't. Okay, perfect. Now it's working back. So once I created my crawler, then let me just zoom it here. I run it. After running that crawler, if you go on AWS Glue on the left under databases, tables, then you will see the table that we created. And if you say the name of the database, it's called Zeppelin database. The names are udata, uitem, user. And you can see also the location of those tables on S3. So keep in mind that this is only the schema. It doesn't have any actual data. So all it has is that the column name, and it's, for example, an integer or a string. And AWS Glue has kind of like the auto schema detection algorithm. And generally, you can adjust that if you want. Because once you finish, it tells you that that's what it figured out. And if you want, you can change it. So now we have our tables on AWS Glue, and it's cataloged. So the next step now. So the first step is that I crawled my data. So I have the data now on S3, and I have a schema on top of it. So it's not going to be only a raw data like a CSV file where I don't know anything about the format. No, now I know the format of my data. The next step is actually to submit an AWS Glue job that will do your data transformation. And here I just want to pause for a second and tell you that in general, if you're at the development phase, it's way more recommended that you build an AWS Glue development endpoint. So if you go to the blog, you will see exactly how you can connect it to Apache Zeppelin and then run your experiment, you test. Once you like the code and you see that it's working well, then you can create your AWS Glue. If the job is very simple, you can do it maybe on the fly. But if there are lots of like merging and stuff that you want to debug, then you can't write the Glue job because it's going to be very hard to debug. So let's assume that we build the code, and I'm going to show you the code right now, which I use the dev endpoint in order to verify that it's working well. So once you're done from your dev endpoints, remember that you have to delete it. Otherwise, you're going to be paying money for it. So I know that one is a little bit slow. That one is a little bit kind of like small. So I'll go on the main stuff that are interesting on configuring your AWS Glue job. So the first thing is the name of the job, which is something you can choose, the role, then the type of the job. And in that case, I'm saying it's a Spark job. and what's the version of the glue. So it's Python 3 glue version 1. That's something you need to specify depending on what your work is, because generally you can write a PySpark, you can even write it on Scala. So that's why it's important that you specify the type here. And then the other important part, as you can see here, is that there is something called monitoring options. Those ones, if you check, then you are going to pay a little bit more money. But what it means is that if I'm saying check for the continuous logging, this means that you're going to log all the results using AWS CloudWatch. And that can be very helpful. Again, if it's something simple, you don't need to do that. But if you're running this in an actual deployment environment, you want to have a log and know if something is going wrong. So once you check that, know that you're going to pay a bit extra money because the CloudWatch will be running. After that, the one of the most important factors to keep in mind is there is something called maximum capacity and the maximum concurrency. In my case, I'm putting it to the minimum, which is 2. And 2 here, they measure the job by something called DPU, which is data processing unit. So in that case, every kind of like one matches to an amount of memory and an amount of CPU. So the larger your job, the more complex it is, the more data you have, the more DPU you need, the more money you're going to pay. So that's why for my example, it's very simple. It's just to learn. And that's why I just put the bare minimum, which is 2. And then you have the timeout. Keep in mind, that's something actually that took me more than 2 hours because I had the timeout. Because again, keep in mind, this is a serverless approach. So even if you have a code that you will run in few seconds, if you put it, there is a lot of large overhead at the beginning, just building up the infrastructure since it's serverless. So make sure that you have a large amount of a timeout because you might think that your job is crashing or it's not doing anything, but actually that it's still figuring out the infrastructure and it hasn't run your job and then you terminate. So make sure to pay attention to the job timeout because after that it will stop and kill it. So I increased it a little bit from the actual default value. Now, once I'm done, I'll just click on save and edit the script because I created the job. Now I have to write the script. So here I have the AWS script, the AWS glue script that will run on my data set. So, and I'm going to just maybe briefly go through it just to give you an idea about what's going on. So when you start your job, basically you have access to all the libraries that you need, including the Boto 3, which is the Amazon library for Python that you can interact with the API. So when you start, it's like any Spark job. You have a Spark context, and here they're going to give you the glue context. So the first line, for example, that I want to show you here is I'm saying from glue context, create a dynamic data frame. So this is like a Spark data frame. And I'm saying the database is the Zeppelin DP, and the table name is user. And now you can see that since I added the schema in the catalog and the data is on S3, I can use this kind of a line in order to read my data as a data frame. So since, again, I don't have a lot of data, and this is a purely tutorial example, I did something that you won't do, of course, if you're in real large data in production, and I converted that data frame into Panda, which is, of course, not optimal. But since the data is small, and I'm just trying this to learn, you can convert it to Panda. And that's what I did for the user data, uitem, and then user. At the end of the day, when I have all of them and I added the column name, I did the merging and the stuff that I want and dropping columns, the data preparation, basically. And at the end, I'm using the Boto 3 API saying that I'm going to have something called Hani data bucket, and I'm going to save the data as mltransformer.csv. So if I go now and click on run job, I should expect I generate it for a bit of time. So if I click on that, it's going to show me that this is the job under run ID. It is running and it has its own logs. And you just wait until it's finished. If there's an error, it's going to give you, instead of running, it's going to show an error. But keep in mind, this can take time because when you run the job, now you're instantiating all the infrastructure because it's serverless. And if you have a large cluster, of course, it's going to take time. Once it's done, if I go to my test bucket, which is Hani data bucket, I find something called mltransformer.csv, which gets the input that I need. And that's why I said before, like having a dev endpoint is very important because otherwise it's going to be very hard to track what's going on. So once I tested it, I tried it, I made sure that the result is good, then I put it on the job that I will schedule or run on demand. So with that part, The end of it is that since I checked the AWS continuous monitoring, I can go there and check the logs. So if you go to the AWS CloudWatch, as you can see, and then you can see the log stream, if you click on it, then you see all the logs and what happened. And again, maybe for this simple example, it's not necessary, but if you have a large example where you're doing lots of things, you need to have the logs. So in case something goes wrong, then you can go back to it. Okay, so for the sake of time, again, if there are any questions, because we have another like maybe 5 minutes for the SageMaker.
Yeah, just a quick question. So to summarize what you mentioned, the Glue is basically a serverless ETL system that, like, let's say you can have a choice of using Apache Spark or I don't know some other frameworks like Rapids, and then you can, without the hassle of setting up, your clusters, worker nodes, things like that, a lot of DevOps, you can actually kind of quickly set up your pre-processing pipeline.
Exactly. And I think, to be honest, when I find there are different things that might be a fit for a glue or not. So for example, like if you're running this on the fly, like that's one of the challenges. And that's why I'm saying this is good for a batch-based job. But let's imagine that I have my raw data and I want to run this on real time. Then glue is not that straightforward. You can do it, but see that the transformation that I just wrote and did, I can expose it to an API. I think AWS, they have a library or a service called, it's more of a Python library called, I think, MLLeap, if I'm not wrong, where it will take, and it's not that straightforward, like you have to dig into it a little bit, where you can wrap the job that I wrote already and expose it as an API where I can do it even during serving time. So somebody, if I say this is the data, I run that transformation now using that library. But for me, the good thing that I found is that in many cases, we have batch jobs that we need to transform, and it doesn't take a long time. If it's like a weekly or a monthly basis, I need to run this transformation. I think without worrying about the hassle, as you mentioned, from the infrastructure, the DevOps, I just write my code, I build a dev endpoint, and actually even for the dev endpoint, by the way, you can do it locally where you install all the kind of like the libraries from AWS Glue, and you can test it locally. That's another thing that you can do where you can save money from it. And at the end of the day, you just put the job and you pay for it when it's running, while it's running. So right now, I know that my data is on S3 bucket and it's ready in a format that's ingestible by the model. So let's focus on the right picture first, just to show you the idea, and then I can describe the code on the left. So the idea here is that if your data is on S3 and it's ready for the model, now we want to use SageMaker. The core idea of a SageMaker, if you want to use SageMaker, you must have your solution containerized. And there are two ways here. Either I can use the off-the-shelf algorithm that SageMaker is providing, or no, I can provide my own container, which means, and that's what I'm saying, that sometimes data scientists have to get a little bit into more engineering, where I understand the structure from AWS SageMaker and how can I containerize my solution and how to run it in a compatible mode with Amazon SageMaker. So the example here is something like XGBoost, for example, if I want to run. So your data is on S3, going back to the diagram on the right, my data is on S3. What I have to provide from the beginning, let's assume I want to use an XGBoost algorithm that AWS has. So basically, every algorithm, if you think about it, is already as in an image inside the Amazon ECR, which is Elastic Container Registry. So on the right side, you can see the EC2 container registry. That's where Amazon saves all the images. So it's like somehow like Docker Hub, if you have your images that you want to put on the outside. So Amazon have their own registry. The first thing is that your image or your code for the algorithm, it has to be on the ECR. So in that case, I'm assuming that there are two cases here. I can have one image for training and serving, if my image is not large, if it's not too complex. But sometimes if training is a lot of packages and serving, it has other packages and more complex stuff, then it's more recommended to split them into two. So that's kind of like a design question. So the way it runs is that the first thing is it will grab the image, depending on the algorithm, let's say like XGBoost. It will go to the ECR, grab the image, and inside it, it will run the training code that they already wrote, and the result would be saved back into a local storage in the container that I'll talk about briefly. And the SageMaker promise is that they will take it back and put it on S3. So the first promise is that they'll take your training data and configuration and everything, and they will put it inside your local container storage in a specific format. The container is taken from ECR, it runs on whatever you had, and then puts the results back to S3 bucket. And then same thing for the serving, where that's my model artifacts, everything is saved there. I take the serving image and the model artifacts and then expose it to an endpoint. So let's look at it a bit more detailed. If I want to run, let's say like the Amazon XGBoost, for example, algorithm. I'm not talking about shipping my own container now. I'm just using their own container. And it's as easy as that. Think about it. The first thing is you see XGB equals SageMaker.estimator.estimator. And then the first thing I want to provide is the image name. And here you see different images depending on the region that you are in AWS. But you can just say it's the image of the name. Let's say like XGBoost latest, for example. That's the ID of it. And then the role, that's for security. And then you can see how many training instance count I want, like how many virtual machines I want, and what's the type of that virtual machine. Because the good thing is that with AWS SageMaker, a lot of algorithms are already parallelized for us. Like you don't have to worry about that. So it will be taken into consideration depending on the algorithm, of course. And then you say, what's the output path? Where do you want your final result? As you can see, like the model artifacts and everything, where it's going to be saved. And you give them the session that you provided. Now, till now, there is nothing. Like that's all preparing the code. Then you say, for XGBoot, set hyperparameters. And in that case, you start giving the hyperparameters for your algorithm in order to run. So I would have eta, object, number, rounds, etc. At the end, I would say when I say XGBoost.fit on that training data on S3, and that's maybe the validation on S3, that's where the magic happens. It will take that container and prepare all the structure needed where it moves your data into a specific location. Your hyperparameters are going to be in a JSON file for you under specific location to train your result. And then your promise to SageMaker is that you're going to save it in a specific place. Once it's done, SageMaker will take it back to S3 and log it. And once it's done, it's as easy as a one line. You can say xgboost.deploy. The instance count, for example, is 1. Again, you can make it more, but you will pay more money. And then what's the type of it? And you have your algorithm running. So that's kind of like in a nutshell. I don't know if I have more time to go through the details.
Yeah, we do have more time. Also, one question was, how does your own algorithm is taken into the container if there is not already an image setup that has all the dependencies?
Yes. Yeah, okay. Yeah, so that's what I want actually maybe to talk about here, which is shipping your own container. Like I will give a high level idea because honestly it takes a bit of time, but I just want to give you the flavor of how you can do it. So if you have your own algorithm, let's say like it's a new algorithm that you want to deploy, it's not on SageMaker, how would I do it? The first thing you have to keep in mind is that you have to build a Docker image for it and put it on ECR and then use the standard for training and serving. So let's give you a bit of an example about how SageMaker works. So basically in SageMaker, the promise that SageMaker gives to the data scientist is that there is a specific layout in folders that will be provided for you inside your container. For example, your training data is going to be under /optml/input/data. So for example, here I'll have training and testing and validation. So if I want as a data scientist now to read my data, since I gave it from S3, SageMaker will move it into my local container storage under /opt/ml/data training. And that's where I read it from. Then if you remember the line, when I set my hyperparameters, if we go back here, you see I said set hyperparameters and all of those. SageMaker will take care of converting them to JSON file and put it inside optml input config hyperparameter.json. So now I can read it from there. The promise that I have back to SageMaker is when I train my model is that the result would be inside a folder called optm/ml/model, and that's my model files. And if I have a failure or anything that goes wrong, I have to put it back into output. And that's for training. So after the whole container the layout is done and the mounting is done, it calls something called the train. And that's what you have in your repository. You should have something called the train and serve. And that's what will be called where your model code is. And if you want to the serving, again, you're very free to do whatever you want for serving. If you're building a deep learning algorithm, maybe you want to use TensorFlow serve. That's one option. In my example, actually, is I used Flask as a REST API with Nginx and gUnicorn and exposed it as an REST API. So you're pretty much, the nice thing about it is that it's very general, but it gives a pattern or a platform for data scientists to build their own image. And that's what I like about it. So another here, if we look at the right, the kind of like the layout for my solution, you see like I have something called the train and serve. And that's where my code for training and the code for serving is layered. And inside, you see the config where I would have my hyperparameters, and then the data under training. That's what I give to AWS SageMaker on S3, and it will move it back to me inside that location. So that's kind of like the idea, and same with serving. So keep in mind that there is a Docker file that we have to fill in. We have to install all the libraries such that I can run Flask, Nginx, or any other library. So it's pretty much dynamic, like building any your own container, but you just have to follow the rules of the layout from the structure such that you can interact with SageMaker. So in that case, this is actually with bringing my own algorithm now. What I did is I pushed it to ECR. I wrote my code. I pushed it to ECR. And then I say, what's the algorithm name? I called it SageMaker Simple Movie Recommender. Then I'm giving the account regions and the stuff for security, and that's the image. Then I say the estimator is coming from that image. And now you can see like the input to the SageMaker algorithm is the container image, the image itself, and it will create a new container from it. I'm saying how many instances, what's the type, and where's my output path. And here I'm saying set hyperparameters, metric equal cosine. And in that case, the promise that SageMaker has to me is that when I run it, I will go to opt_ml/data/training. I'll find my training data. If I go to opt_ml inputs and then hyperparameter.json, I will read it and I'll have something called metric, which is the cosine. At the end of the day, I can do a fit and then give the data location for my input. And that's where it starts kind of like migrating all the stuff and putting the structure. And to deploy, that's exactly for the same thing. One thing that is a little bit annoying, I would say, for me that I found is kind of like the serialization that you have to take care of. Like, for example, what's the serializer for your data? So I'm using a simple CSV serializer. And I'm saying for that model, CF model, which is a collaborative filtering algorithm, deploy it as one machine on that instance, and that's the serializer. And then I can invoke my endpoint. So in order to run a serving, there you have to implement two things. You need the invocation, which is the serving for REST API, where you give an input and it gives you back the result. And there is kind of like the other thing, which is the ping for health check, where SageMaker checks the ping function. And if it's not working, then it will figure out that the server is dead, the service is dying, or there's something wrong with it. So in my case here, if I say predictor.predict, and I'm giving the two movies, for example, 1 and 10, and saying, give me the top two similar movies, you can see the top two for the first and the top two for the second. And again, the idea here is more to teach myself. It wasn't to build something end-to-end from a production point of view, but you can see that exactly if I convert this and I have like a mobile application or a web application, it's very straightforward. You can feed whatever input you need. If you have, for example, a UI, you can choose the movie. It will get the ID of them, pass them to the REST API, and then you get all the results back with the similar movie with the ID, the creation date, and the similarity with that movie. So it's like a collaborative filtering algorithm. And at the end, these are the resources that for my blog that I took most of the images, most of the code, all the details you can find there.
Awesome. So I have a couple of questions received from the audience, and I have one or two of my own questions too.
Sure.
So maybe we will start with the glue questions because it came first. So in your presentation, you had to connect to S3 storage in order to access your data. So do you know if there is any option to connect to different data sources? Let's say we have a corporate data space. It's like SQL Server or Postgres, or even MongoDB.
You can. There are other options. I know that there are other options like the Amazon, I think Redshift. I don't know how it will work with external storage, to be honest. But if it's inside Amazon, I'm pretty sure they have different ways where you can grab your data from. But if it's from something external, I'm not sure how it will work.
Right. Thanks. Another question was about how GlueETL is different from Spark schema on read features.
On what, sorry?
Spark schema.
I see. So, but this part, I'm not sure if the underlying implementation of Amazon is taking that as an open source tool and rebrand it. But it is, the idea is pretty much similar. Like there's an auto schema detection, whether it's using that algorithm from Spark or Amazon have their own algorithm. So there, I didn't dig into the source code of the AWS Glue, but there might be a possibility that they took that code, maybe changed it a little bit, and now you have an auto schema detection. But the idea is pretty much similar. And in order to query the data and even put it after that on, as I said, like on Amazon Redshift or different like data warehousing tool inside Amazon, you need to have that schema.
Right. So the other question is about SageMaker. But for the audience, please feel free to post your questions because I have 2 questions left, if there is any. So the Docker container is supposed to implement kill signal from SageMaker. According to their documentation, how do you do that?
So like the challenge is I don't know if I can share the screen here. Let me see if I can open the actual solution. So at the end of the day, like if there is, for example, an exception, you have to, for example, I can see it on my other screen that you can use the sys package. You say sys.exit and you give the error code of 255, and that will make SageMaker aware that there was an error running your code. So that's why, again, there are like certain standards if you go to the code that we need to follow. But for me, to be honest, the most important learning, at least, and even what I'm trying to do right now within RBC is to inspire from that kind of like layout. And instead of having data scientists handing over random Python code or just in a container, at least now I have a standard where anyone can push. And if we build something like SageMaker, it's not going to be as simple as, oh, like these nice API, but at least you can provide a JSON file and all these input and write an application that takes care of your container and you can scale. So there is kind of like a unification in how you deliver your model or your solution.
Right. That makes sense. So there is one more question I have. So for the basically, like you explained the pipeline, but so is there like an event triggering kind of code that, let's say, can you use this pipeline for a full CI/CD? So you train your model. Once you approve it, it will trigger the deployment, and it's automatically deployed in your production through SageMaker.
So I haven't tested this, but there is one thing that I didn't mention here, that when you run your code on SageMaker, generally you connect to a Git repo. So the fact that you can connect to a Git repo, I'm pretty sure that they have something like Jenkins. I haven't tried it, but I'm pretty sure that there should be a way where, but keep in mind, like when you do a new that's kind of like where, I don't know how straightforward it is, because once you deploy, once you change your SageMaker code, it means that you have to deploy something new to ECR. And when you're calling your algorithm, you have to know that this is the latest image that you have pushed. So even if it's not there, and I doubt that it's not there, but even if it's not there, I don't see it very much like complex to do. Because basically with SageMaker, you have access to a machine, you can install whatever you want, and at the end of the day, you can just write a red flag somewhere on S3, what's the latest image, and on your code, you just take that name of the image for the latest deployed one.
Right. So the last question I received, it's what are your thoughts on AWS Personalize, which is used for recommender engines? I think out of the box, kind of.
Like to be honest, I can't speak about it because I haven't worked with it. I have read their kind of like documentation, but again, from a practical perspective, the idea sounds good. but the implementation, I haven't tested it myself. But when I read their documentation, the good thing about it, and that's what we're trying to do even within RBC, and I'm pretty sure all organizations are trying to figure out a pattern for the problem, whether it's like a recommendation or a natural language problem. The good thing about it is that they give you a pattern where you don't have to worry about all the infrastructure or anything inside the model. The challenge that I have, again, with those kind of techniques, it's not only with personalized specifically, is the data science somehow is becoming more commoditized, that a lot of people are going to start using it, but using it in a wrong way. Because I know that there are, for example, hyperparameter algorithms to figure out the results for you. But if you're a technical person, that's totally fine. The challenge is that if we're working inside a business, the statistical best result might not be the best business result. And having an absence on an understanding of what that parameter is going to affect in your output, that can be a bit tricky. So again, I can't comment a lot on AWS personalized, but I think from the idea and the documentation, when I checked it, the idea sounds good, but the implementation, I don't know.
Gotcha. So we received a couple of more questions. Does Glue database comes under the umbrella of data lake?
Under the umbrella of data lake. My suspicion is yes, but I can't. The true answer is I'm not sure. Because I know that there is, at the end of the day, you have a database that will contain your schema, similar to the data lake idea. But internally, I'm not sure.
Yeah, it makes sense because it's using S3
yes.
Anyway, so S3 could be part of any other AWS services.
Because see, like these questions are great, and they are more on the implementation detail of the service. So that's why what I'm trying to do here, and that's the message that I'm trying to give, is that there are cases where I don't need to dig too deep details in the engineering, and same with the data science part if an engineer is working with it, but at least understanding how can I interact with it. Because the next step, if you go, for example, to the blog, and you'll see like with AWS Lambda and AWS API Gateway, like behind there are a lot of work and how they scale it. I don't know, for example, if they're using something like Kubeflow or others. That I'm not sure, but at least it took care of the scalability for me. And as a data scientist, all I worry about is that my results and my model is working well.
Yeah, that makes sense. It creates a layer of abstraction for a lot of this stuff. So no, that makes sense.
And it doesn't mean that it's valid for all solutions, because sometimes you might have a specific problem that you need deep technical knowledge inside the engineering side of it. And in that case, AWS maybe is not the best. But for many problems, I would say, many even actual business problem, if you don't have a PII problem putting data on AWS, it sounds really good because you don't have to worry about the infrastructure and you save a lot of money from other stuff.
Yeah, gotcha. So one of our audience, he asked about like, is there a version control on the model? So if the model is saved, is it like already automatically versioned, or how does it work?
So generally, when you push your model, because at the end of the day, that's an ECR job. I'm pretty sure that within ECR, you can change that. I haven't done it, but I'm pretty sure there should be a way to do that.
It's possible. Okay.
Because actually, even if you go here, let me just go back, just to show that it is possible. If you go here, you can see that in containers, you see like that line where I'm specifying what's the name of the image. And at the end, you see like it's XGBoost latest, which gives you that there is a version for it. So you can specify, like any Docker, like Docker Hub, where you specify the version of your image. So it's pretty much doable that you can do that, yes.
Yeah, but let's say when you save your model, probably in S3, is it already versioned, or you have to implement that versioning yourself?
Oh, so you're talking about the versioning of the output.
Output, yes.
I see. Like that, I haven't tested. I know that they have lots of analytical tools after that you can run on the model, but I haven't investigated that.
Okay, thanks. And someone was mentioning the service is really expensive compared to rest of the AWS services. And it was my question too. Let's say movie lens the data set is very common across like the projects that are trying to build recommender engines. Like, For, let's say, for a mock-up, like using movie lens, do you have a rough estimate of how much it costs you to do that on AWS?
Like, see, all that work that I did with the dev, again, my data is not large. That's a very valid question. If your data is large, you will pay money. And that's why I'm saying you have to figure out between having IT people and support people to figure that out where, or no, it's better to put your data there, pay a bit of money. But again, you save yourself the hassle. So I think, and I strongly think that if you are a small to medium-sized business, AWS would be the best fit for you. If you're a large organization, you might start thinking about having your own because now your data is scaling massively large, and then you're going to pay a lot of money for it. But going back to the question about how much money you pay, I think for all the stuff that I showed you with the endpoint, I didn't get more than $15. I didn't pay more than $15. Because the other thing is I'm very, very careful when I'm trying those stuff. Like I don't run the instance before I know my container. I run it locally. I didn't talk about that, but there is a way for your SageMaker model to test it locally before. So if you go back here, for example, to this image, you can see that there is something called here local test, where I have a test directory and I'm mocking up the input config, the data, the model output, and the output. When I run my Docker image locally, the container locally, I mount where the data is to those locations. And that's how you can do it with SageMaker, where you test it locally and then you run it on SageMaker. So if you are very careful and your data is not crazy, I don't think it will give you a massive amount of money. Now, keep in mind though, deploying the service can be costly because this is running, and even the same thing, like if you're putting training is different. You run it one time, you both pay for it, and then you terminate the process. But once you want to deploy, then that's right. Then you're going to pay a lot of money. But as I said, at the end of the day, it will scale up for you. I didn't talk about this, but with Amazon SageMaker, there is a way that's kind of like scale up for you, like the number of instances and things like that. And it saves the hassle for it. So that's why as a business owner or as someone working in a business, you have to think about how much benefit versus money that you are paying for it.
Right. That makes sense. So I don't think there is any other questions. I think we can close the call. Thank you so much, Hani, for the great presentation. And also thank you all the audience for their time. And this was a really great talk. So if there is nothing to mention, Hani, we can close the live stream.
Oh, thank you so much. I want to thank you for the organizers and thanks for the audience, and hope that they get kind of like a useful stuff out of it. And again, to recap, the final thing that I want everyone to take is that as a data scientist, please try, and if you're working in 95% of the industries, try to learn a little bit more about engineering, even with the cloud or with any other kind of like off-the-shelf services, not just only the deep learning or the model itself, that's the fancy one, because there are processing before and then after that how you deal with the model, and that will give roughly an idea about it.
Awesome, great. So I wish everyone a really great day and stay safe. Thanks.
Thank you.